The universe we inhabit is expanding at an extraordinary and accelerating rate, presenting one of the most daunting challenges in modern science, defining its limits or even understanding its full magnitude. Unlike a traditional object with clear edges, the cosmos has no definitive boundary that we can currently detect or measure. Its rapid expansion stretches the very fabric of space itself, distancing galaxies from one another at incredible speeds. This makes it nearly impossible to determine how far it reaches or what lies beyond. However, with the advent of cutting-edge astronomical tools, most notably the James Webb Space Telescope, we now have the ability to observe deeper into space and further back in time than ever before. These advancements allow scientists to uncover regions of the universe that were previously invisible and inaccessible, revealing new information about how everything began and how it continues to evolve. With each new discovery, researchers such as physicist Brian Cox are helping to paint a more detailed and astonishing picture of the universe, one that exceeds earlier conceptions by orders of magnitude. Based on observations of the known visible cosmos, scientists now estimate that there are approximately 2 trillion galaxies within our observational range. This number alone is almost impossible to fathom, yet it only accounts for a limited section of what could be an unbounded universe. Beyond the edge of our observational capabilities may lie a realm so vast that it defies current mathematical and conceptual frameworks. If the universe is truly infinite, as some theories propose, then what we see represents merely a sliver of a far more immense and complex reality, one that we are only beginning to grasp. It's important to remember that we are not merely observers looking out at the universe from a distance. We are fundamentally part of it. The atoms in our bodies were forged in the hearts of ancient stars that exploded billions of years ago. In a very real sense, we are stardust material formed by the universe, now capable of contemplating its own existence. Our minds and instruments allow the universe to become aware of itself. The James Webb Space Telescope, through its sensitive instruments, serves as a kind of time machine, letting us look back billions of years to see the earliest light emitted. After the Big Bang, through this telescope and others, we embark on a profound journey through time and space, mapping the intricate architecture of existence. To even begin appreciating the scale of the cosmos, we must start close to home within our own solar system. Let's imagine a scenario in which we travel at a constant speed of 70 miles per hour, comparable to driving on a highway. At that rate, it would take around 15 days to travel the distance of Earth's equator. Reaching the moon at that speed would take roughly 5 months, assuming a direct path. Mars, when it is closest to Earth, would still require approximately 63 years of continuous travel. Neptune, the most distant planet in our solar system, would take a mind-bending 4,400 years to reach. These numbers alone underscore the massive distances even within our local celestial neighborhood. Consider Voyager 1, a space probe launched by NASA in 1977. Despite traveling at an astonishing 38,000 miles per hour, it took Voyager 1 more than 35 years to cross the threshold of our solar system. It finally entered interstellar space in 2012, and it continues to drift through the void, sending back data from beyond our sun's direct influence. Even light, the fastest known phenomenon in the universe, capable of circling Earth 7 times in a single second, appears sluggish when confronted with the vast distances that characterize space travel. The time it takes for light to reach distant celestial objects can span decades, centuries, or even billions of years. And yet, despite the vastness of our solar system, it is tiny when compared to the enormity of the Milky Way galaxy. Our galaxy is a sprawling, spiral-shaped collection of roughly 300 billion stars, most of which are orbited by planets. Some of these planets may even host conditions suitable for life. The nearest star system to us, Alpha Centauri, is located 4.3 light-years away. If we were to travel toward it at the same speed as Voyager 1, the journey would take an estimated 70,000 years. This comparison serves to illustrate the mind-boggling distances that separate even the closest stars within our galaxy. One particularly striking example of these distances is Betelgeuse, a red supergiant star situated approximately 640 light-years from Earth. When we gaze at Betelgeuse in the night sky, we are not seeing it as it exists today, but rather as it appeared more than 6 centuries ago. The light we observe tonight began its journey long before the dawn of modern civilization, well before Columbus set sail across the Atlantic Ocean. In essence, we are looking into the past every time we gaze up at the stars. Our own radio signals, which humanity has been transmitting into space for just over 100 years, have only managed to reach about 15,000 nearby star systems so far, a tiny portion of the stars that populate the Milky Way. To visualize just how immense our galaxy is, consider this analogy. If the entire solar system were reduced to the size of a quarter, then the Milky Way would be about as large as the continental United States. Within that vast region, our solar system is merely one of hundreds of billions. And beyond the confines of the Milky Way lies an even more staggering reality. Estimates suggest there are at least 1 trillion more galaxies spread throughout the observable universe. To conceptualize this number, imagine 1,000 dogs. Now imagine 1,000 groups of 1,000 dogs. That gives you 1,000,000. Multiply that by another 1,000,000, and you begin to approach the number of galaxies we believe to exist. The scale is almost too large to conceptualize, and yet it is supported by the best observational data we have. Among these galaxies is Andromeda, our closest galactic neighbor. Located about 2.5 million light-years away, Andromeda is on a collision course with the Milky Way, despite containing roughly 1 trillion stars, more than triple the number in our own galaxy. The space between individual stars is so vast that the likelihood of stellar collisions during this merger is extremely low. Over the course of billions of years, these two galaxies will slowly merge, forming a new, larger galaxy. From the perspective of deep time, this is just one of countless events shaping the evolution of the universe. If we zoom out even further, we find that the Milky Way and Andromeda are part of a group of galaxies known as the Local Group, which includes over 50 members. This group belongs to the larger Virgo cluster, home to more than 1,500 galaxies. The Virgo cluster itself is embedded in an even grander structure known as the Laniakea supercluster, which contains approximately 100,000 galaxies. Each of these galaxies may hold hundreds of billions of stars and potentially even more planets, many of which could harbor forms of life or conditions still unknown to us. And yet, even Laniakea is just a small part of the greater cosmic structure. Beyond Laniakea lie millions of other superclusters, roughly 10 million. According to current estimates, each one made up of galaxies too numerous to count. What we have observed and charted represents only a fraction of what's out there. It's likely that hundreds of billions of galaxies remain unseen, their light either too faint or too distant to detect with current technology. The cosmic web, the vast network connecting galaxies and clusters, is made up of long filaments of dark matter, gas, and dust. These structures stretch across billions of light-years, linking galaxies like threads in a vast, interwoven tapestry. Within this immense web, we find extraordinary phenomena that reveal the dynamics of the universe. Supernova, the explosive deaths of massive stars, scatter essential elements like carbon and oxygen into space, enriching the interstellar medium and seeding the formation of future stars and planets. Black holes, with their immense gravitational pull, warp space and time and influence the shape and behavior of galaxies. Quasars, the intensely bright centers of certain galaxies, powered by supermassive black holes, serve as cosmic lighthouses, allowing us to study the early universe.